Hello, everybody. This is our submission for BGSU's 12-hour hackathon. We built a search engine type of thing using a RAG model in the backend. The idea is we combine web search as well as local search to better show what things are available and how to provide proper answers. We use Next.js as our front end, or like a full stack thing, and we use Favicon on our back end. We also use Tabify as our backend service for doing a web search, grabbing information, giving it to an LLM, and generating answers. We also use a C++ crawler that crawled all over the BGSU website. We were able to get 45,000 links from there, and we use these links, the things from here, they were converted into vector embeddings, stored in a vector database, and retrieved using a RAG model in the backend, and supplied it to the web search to just give additional context when you cannot find those little files that are hidden somewhere. So the idea is pretty simple. We have a web app. We made a web app that's able to take in a question that you give. Let's say we have a sample question here already. Once you hit and give it a question, give the tool the question, and once you hit enter, it goes through multiple steps. One of the things we use our backend is Fast API. For each query call that we make, Tabify, which is a search provider, is set to Tabify using the environment variables that we have in the backend. It gets the top 10 web results, so there's a web search done for this. In addition to that, we also give additional context from the backend, where we locally also have things stored in a vector database as vector embeddings that we have crawled from the BGSU website and stored using a C++ crawler. We scrape each page using Beautiful Soup, chunk the text, and embed it using OpenAI's text embedding model. So we use that as our main backend, or the main LLM that we use. Retrieval runs in memory with FAISS for fast cosine similarity. So there's some sort of cosine similarity being done, because that's how we try to see what the closest documents are. We pass the best chunks to OpenAI GPT-4o mini model, so every answer is grounded to the latest web search. In addition to that, we also provide the vector embeddings that we have that are closely related to what the search is, and we supply all of this to GPT-4o mini, and it provides a response like you did see here. The API response will generate answers, citations. It provides citations, and it shows you the source. So if you want to view the source and where the data is coming from, you can also do that. That's basically it. So for the front end, we use Next.js, Tailwind, and Daisy UI to make a beautiful looking front end. You see all the components that we use. These are from Daisy UI and Tailwind. We render the LLM answer with React markdowns. So formatting looks clean. So for formatting, we did something, that's a little trick with it. Below, we show the top web hits that show the closest web matches that are shown. The hero stat cards are dynamic. They show how many sources were scanned, how many chunks were fed. On top of that, we also have the vector embeddings that are coming from the backend. So it's a combined process that shows everything. It's context rich. It has a lot of context, so it's able to generate answers, something like that. Just for the sake of doing it, let's also try another query. Another thing we wanted to implement how many sources were scanned. It shows you how many actual documents were scanned from the web. We show how many context chunks, and we show the latency, which is the time taken for that query to run and generate an answer. Not only that, we also go a step ahead, and we just get the graph of what links it followed, how it got what it did, and we plot it here. If we expand it, you can see there a little more clearly. But that's basically it. We take in a response, we take in a query, we get response, we do a web search, we get responses, we supply it to the LLM, we use vector databases and vector embeddings from the data we crawl, and supply that to the LLM as well. So overall, it has a lot of context, it doesn't miss anything, and it tries to give you answers based on what you need. Just for the sake of testing, let's also just do one more. There you go. It's going to take a little bit, but you see why you understand why it takes so long, because there's so much context that it's taking in and trying to generate. So there you go. That's our project. Just for the sake of that, we need a question about the CS department, so we're going to do another one on CS department. But yes, apart from that, that's our project. Thank you very much. There you go. Another one. Thank you.